Alright guys, so I am going to do a quick recap of all of our points of concurrency. So on this first one here, we are going to talk about the centroid. Now, if I'm trying to draw the centroid, then the lines that I need are the medians, which to draw the medians, you need to find the midpoint and connect it to opposite angle. So, if I was looking at the line AB, I'm going to find the midpoint of AB. I would count my slope. So I went up 1, 2, 3, 4, 5, 6 over 2. But rather than traveling 6 over 2, we're going to do 3 over 1. So I go up 1, 2, 3 over 1. And so that midpoint is located at 2, 1, 2, 3, 4. Then I need to connect it to the opposite angle, which the opposite angle here is C. Now technically to find the centroid, I just need 2 medians. So now I could find the midpoint of BC, for instance. And so if I count from B to C, I have to go down 1, 2, 3, 4 over 1, 2, 3. So I went down 4 over 3, and I would do half that. So 2, and then over 1.5. So 1, 2 over 1.5. Which puts me at that spot right there, which is definitely in between. So 1, 2, 3, 4.5, comma, 3, 4, 5. I connect that to the angle opposite, which is A. Now, if I were to write the equation of those lines, we would put it in point-slope form. So I have the point that I'm going to use, but I need to find the slope of this line. So the slope of my midpoint, let's call this one M and that one N. The slope from M to C is down 1 over 1, 2, 3, 4. So down 1 over 4. The slope of AN is up 1, 2, 3, 4 over 1, 2, 3.5. So up 4 over 3.5, which is so gross. If I were to write the equation, I would put it in point-slope form. I would write y equals -1/4 parenthesis x minus 2 plus 4, because that is your slope and that is the point that it goes through. Here I would probably change that, but I would write y equals 4 over 3.5 parenthesis x minus 4.5 plus 5. Okay, once I have those, then I can distribute and get them in standard form so that I can set them equal to each other to find the centroid, but also like it just looks at my centroid is at 1, 2, 3-ish, comma 1, 2, 3, 4-ish. Okay, so hopefully that helps. The other S1 that you need to find. Now the centroid doesn't have any super fun stuff with it. I should just say that it's got that 2/3, 1/3 thing. And it's your center of gravity. So that's kind of the fun fact about your centroid. Okay, your other C1 is the circumcenter. If you want to draw your circumcenter, then you need to draw the perpendicular bisectors. To get the perpendicular bisectors, you need to find the midpoint and opposite reciprocal slope. And draw that. Okay, so let's say we're going to do that midpoint of AB again. We already know it from the last time. It was at 2, 4. So I can go over 2 and then up 1, 2, 3, 4, right here. But then at that spot, I need to do the opposite reciprocal slope. So the slope of this line, if you remember, was 6 over 2. The opposite and reciprocal of that is negative 2 over 6. So from M, I'm going to go down 2 over 1, 2, 3, 4, 5, 6, and then I connect those dots. So you're not connecting to a pre-existing point, you're having to get a new point. Then if I wanted to write the equation of that line, we can put it in point-slope form again, because here is my slope, so negative 1/3 if we reduce, and then there's my point, so x minus 2 plus 4. Okay, then we got to do it one more time, and just because like n was kind of in between, let's see if we can't do AC. Maybe AC will be nicer. So if we do AC, find the midpoint, I would count up 1, 2 over 1, 2, 3, 4, 5. Still sucks. So to find halfway, we're going to do 1 and then over 2.5. So up 1 over 1, 2.5. Which puts me right there. Which is located at 1, 2, 3.5, comma 1, 2. Now at that spot, I don't connect it to a pre-existing point. I have to do the opposite reciprocal slope. So I'm going to go back to the one that was nice and not a decimal, and I'm going to change the sign and flip it. So from here I could go down 5 over 2, but that feels really far away from my triangle, so I'm actually instead going to go up 5 back 2. So 1, 2, 3, 4, 5, and then back 1, 2, and you're in between, so make sure you stay in between. And then I connect these 2 points. Okay, so once I have that, I can write my equation again. Y equals my slope, which is negative 5 over 2, parenthesis x minus 3.5 plus 2, because that was your midpoint. Okay, so this is where I would then do substitution. And if I were to do this, like when you distribute and combine like terms, you're going to have to add fractions that don't have the same denominator. And same thing here. So just be careful with that. But it looks like that your circumcenter is going to be around 3, 1, 2, 3, 4-ish. A little less. Now the circumcenter is nice because it is the center of a circle that goes through the angles. Of your triangle. So it's like that outside circle. Okay? Another one that we might do is the orthocenter. Your orthocenter is created by the altitudes, and your altitudes need perpendicular slope and angle across, or angle opposite. So kind of like the median, but kind of like the perpendicular bisectors. Okay? So if I find the slope, let's do slope of AB. That slope we've counted a bunch of times. It's up 6 over 2. But I need it to be perpendicular, so negative 2 over 6. Now because I'm on line AB, I'm going to do this slope to the angle opposite, which is at C. So the letter not included. Okay, so I actually need to go to C and do down 2 over 6, which again feels like the wrong direction. So instead I'm going to go up 2, back 6, and then connect C to my new dot. This should look 90. Hopefully it does to you. Okay. If we needed to do that again, we could do like the slope of AC, which again we found was up 2 over 5. Opposite reciprocal of that will be negative 5 over 2, but I need to do that at the point across, so the one not included, which is B. Okay. So I go to B, and I go down 1, 2, 3, 4, 5, and then positively 2, and you connect B to that new point. Which again, that should look 90 right there. And then wherever they cross right here is your orthocenter. Okay, and you could write the equations for those lines, or you could find the distance of those lines. For distance, remember we wanted to use the square root of rise squared plus run squared. But your orthocenter is not all that neat. Like, it's just sometimes inside, sometimes outside, or sometimes on. The reason that we might need an altitude, though, is I might need it to find the area of a triangle, because an altitude is a height. So here, this altitude goes with this base, or that first altitude goes with base AB. But either way, the area of the triangle is consistent no matter which height you use. Okay, last but not least is our incenter, which normally we don't do on graph paper, but I will talk about it. And the reason that we don't is that the incenter is created with the angle bisectors, and that's just not something we can measure on here. So you have to use a protractor. So must use protractor, measure angles, and cut in half. So using my handy dandy protractor here, I would go to maybe angle A. I'd follow it out to 0 and walk my way around, and that one seems to be at 50 degrees. C, if I follow this out to 0, I have to go all the way out now. And that goes up to here, which is on the outer loop, so it seems to be about 78 degrees. Then angle B, if I follow this out to 0, I'm on the outer loop again. That seems to be hitting at about 56. We just need to cut each of those angles in half. So back at that 50, if I cut it in half, I'm going to make a mark at 25 degrees and draw a line connecting your angle in that mark. And then if we cut the 78 in half, we're going to be at, what, 39. So I mark off 39 degrees, almost on the 40, and then connect the angle to that mark. Right here should be your incenter, which I can like count and approximate. Now your incenter is cool because it is the center of a circle that goes through the sides of your triangle. So it's the circle inside. If you need a circle to the inside, that's the one you want. Okay. So hopefully that is helpful to you, and you can like pause or go back if you need to see something more slowly. And good luck.